right, I had some questions from people on number 27 and 28. Number 27 gives you an equilateral triangle. Of course, we know it'll have 60-degree angles. We know that the area is 9 radical 3. We want the length of the side. So later we're going to have a formula for the area of equilateral triangles, and I suppose if you've looked ahead, you could use that formula. This was actually supposed to kind of help us develop the formula. So imagine that the side lengths were each s, or x, or whatever you want to do here. What you've really got is an equilateral triangle. And an equilateral triangle has 60-degree angles. An equilateral triangle splits into two 30, 60, 90 triangles. So if this whole side is s, this would be 1/2 s. This side would be s. And remember that this side gets multiplied by radical 3. So it would be 1/2 s times the square root of 3. I'd probably write it as radical 3 over 2 times s. Okay? So we have radical 3 over 2 s with s. Remember, the area of a triangle is just half the base times the height. Okay? So you should be able to say, all right, I'm going to take half the base is s, times the height, which is radical 3 over 2s. And I want that area to work out to be 9 radical 3. And you should be able to solve that equation. So again, not a whole lot of geometry here once you realize that you have 30, 60, 90 triangles. It's all algebra 1 from this point. So a couple of different things here. I'd probably multiply the 1/2 and the radical 3 together, write it as radical 3 over 4, multiply the s's and get s squared equals 9 radical 3. Couple of things here. I would probably divide both sides by radical 3, and that'll knock out the radical 3. If I divide by radical 3 here and radical 3 there, radical 3 divided by radical 3 is 1. So we've got 1/4 s squared is equal to 9. Multiply both sides by 4, you get s squared is equal to 36. And of course that tells us that the side lengths are going to equal 6. So challenging problem, but it will be a little bit easier. Make sure you watch the video where I show you how to find the area using the formula for the area of an equilateral triangle. Save you a little bit of time on this kind of problem, but some good algebra there and a good reminder of how these formulas work. All right, let's take a look at 28. 28, I think there are different methods for 28. Honestly, I'm trying to come up with the quickest method I can here. I thought, oh look, I'm going to be able to make a 45, 45, 90 triangle right here. And I was hoping this was a 30, 60, 90, but if you subtract 45 from 120, I think you're going to get, is that 75? Yeah, that's 75. And that means this angle here is going to be 15 degrees. So we got a 45, 45, 90 triangle, but we don't have everything we need here. Honestly, I would probably just use trig and kind of hammer my way out here. The only right angle we've got for sure is this angle right here. So I need this side length and I need this height. And by the way, this length will be the same as that length, which would give me the whole base. So I really just need to find this side and this side of this triangle. And remember, that's why we did trig, okay? Trig's gonna come back again and again and again and again. If you see angle measures and it's not a 30, 45, or 60, it's not one of those special triangle relationships, or in this case, if one of the triangles isn't, you're gonna have to do trig, okay? So let's take a look here. Let's find this side. I'll call this side x. We've got an angle measure, the adjacent leg, and the hypotenuse. Remember SOHCAHTOA, that's a cosine of 15 is equal to the adjacent over the hypotenuse. We can multiply both sides by 8 there. So x is going to be whatever 8 times the cosine of 15 is. I'll stick that in my calculator. That's about 7.727, okay? And again, I'd go several decimal places there. I need to find this other side here. I need the altitude of the triangle, so I'm going to call that y, okay? And I've got an opposite side and a hypotenuse. That's a sine of 15 is y over 8, and I can multiply both sides by 8. So 8 times the sine of 15 is going to give me y, and that's about 2.071. And since this is a 45, 45, 90 triangle, these two sides are going to be the same, so that's also about 2.071. So we can take half the base is both of those added together, so that's about 2.701 plus 7.7274 actually on my calculator. Okay, that base is about 9.7979 times the height, which is about 2.071, okay? And getting an answer of approximately 10.146, something like that is my final area. Okay, so a little bit trickier, but that's what's going on.